Okay, today I'll be showing you how to use the AC manifold gauges for your air conditioning. Blue is for your low pressure, red is for your high pressures. And the numbers vary depending on the temperature of the day, how hot it is, and how much refrigerant you have in the system. But normally you want in the low pressure side, the blue side, around 30 to 40 psi. Those are normal ranges. The red side, high side, normally is higher, around 100 psi to even 200. Just depends on the car. Some cars run higher pressure, some run less. This is for a R-134a refrigerant. So you'll have the coupler style fittings where you have a sleeve here and then it snaps into place, and then you got the knob here to retract the needle. And you want to make sure that this needle is fully retracted before putting it on your test ports. So if I turn this knob clockwise, the needle comes out. As you can see, it extends outward, and that needle will push on the Schrader valve at the test port and release the gases, the refrigerant gas, into the line. So it's important that you have that needle retracted completely, so when you're putting on your fittings, you're not releasing any of the refrigerant into the atmosphere. As we know, that's very harmful to the environment, puts holes in the stratosphere, allows UV rays to enter Earth, harms the ocean floors, causes skin cancer, right, from the ultraviolet rays. So it's important to, do this the right way and make sure no refrigerant escapes. It's the same thing with the high side coupler. You have the sleeve here. You pull the sleeve back and you put it on the fitting, release the sleeve, and it snaps into place. And then you have your needle in there as well. You turn it clockwise, the needle comes out. You turn it counterclockwise, the needle retracts. Okay? Then you have your yellow line in the center. This one is not a coupler style. This one is a screw-on fitting, where the thread's on the inside, and you need to screw this on. This goes to the refrigerant tank, and this is where you would charge AC refrigerant into. It'll go into this yellow line, into the sight glass block, and crosses over to the low side line. That's where you want to charge, and that's by opening this valve here. So when you open this valve counterclockwise, it allows refrigerants to go up this yellow line and then left into the blue line and then into the system. If I were to open the red knob, if I turn this knob, then refrigerant will be allowed to go into the sight glass, go right into the high side, which is what we don't want. So we're going to make sure these two knobs are always closed before we use it. If we don't want any pressures crossing over, we don't want the high side and low side crossing over. These valves act as a bridge for the two. And when we're going to check our pressures right now, we want to make sure that this is closed so we don't get an inaccurate reading. So first we got to find our test ports, and here we have one that's for the high side, and then this one here is for the low side. They look like this, coupler style fittings on the R-134a systems. For R12, the older systems, they have threads. They're screwed on. They don't have this kind. So if you wanted to retrofit the R-134 from R-12 system, then you would have to replace these adapters, these test ports. So when you're putting them on, you just put it over, make sure the needle is fully retracted, right? Once again. And then you push down on it and then pull the sleeve back and then push forward. And then it snaps into place. See, shake it to make sure it's nice and tight. Same thing with the high side. Make sure the needle is retracted. Here's the test port. You're gonna pull the sleeve back. Hold it back. Place it over. And push down. There we go. And now you're gonna open the system, turn it clockwise. And as you're turning it clockwise, the needle is coming out and it's gonna push on the valve to release the gases into this high side line and into the gauge here. So same thing with the low side. We're gonna open it. Gases gets released into the low side and into the gauge here. Okay, we're gonna read the gauges in a minute after we turn the car on and see if there's any refrigerant in the system. So the vehicle's on now, and these aren't real readings. There's still pressure in the lines. There's no refrigerant in the system because I released it. It should show 0. So you go into the car. And you're gonna turn on the AC. Make sure the AC button is on. It's usually a snowflake icon, and the LED light should come on green like this. So that's off and that's on when it's light on. Okay. Make sure your settings are all the way down. Cold, 59 degrees Fahrenheit, and see where the fan is. You can set it to medium, and it's not blowing cold at all because there's no refrigerant in it. And we're gonna charge it and check again. Okay. So to charge it, you need, well, you can get one of these tanks. This is R-134a. This is 30 pounds for $100. And we'll put the yellow line onto this fitting here. See how it's threaded on? And then open up the valve and allow refrigerant to enter it. So here's the yellow fitting, and just gonna screw it on there like so, and open the valve. Now you want to flip it over upside down like that. so that all the refrigerant drops down into the yellow line, up into the side block, and then cross over to the low side. So now we're going to open the low side and allow the refrigerant to enter the line, the system here. That's going to enter through there. Okay, so make sure this is closed and this is open. And it's hard to see, but you should see flow in through this sight glass. That's what that's for. The sight glass is to show refrigerant flow coming from the refrigerant tank to the yellow line, up over into the blue line. And it goes into here, into the compressor. The compressor is right down there. It's not engaged because there's no pressure yet. So the HVAC control module is going to disengage the clutch to protect the system from running dry. And until sufficient refrigerant enters the system, it's going to stay disengaged. And once we get refrigerant in to the proper amount, then the clutch will engage. There we go, the clutch just got engaged. As you can see, the clutch pulley is spinning with the pulley itself. The clutch and the pulley is spinning together. And we should see an increase on the low side and an increase on the high side. Okay, it's still low. It should be at 100 to 150, and this should be 30 to 40 psi. So it's rising above 40. We're gonna have to wait and let it equalize. So it's still not blowing cold, still warm. And if you touch the tank, it gets cold because the drop in pressure is absorbing all of the heat surrounding it, and this line is cold right now because it's absorbing all of the heat surrounding it. Refrigerant boils at a very low temperature at 32 degrees Fahrenheit. So this isn't cold just yet. We're gonna have to wait. The clutch is engaged. Let me show you what it looks like when it's not engaged. So you hit this button, the light goes away. And then as you can see, the pulley and the clutch is no longer spinning together. The clutch has been disengaged because I pressed the button. So if I go back and press it again, it should engage. You can hear the idle change. RPM increases, that's normal because that's an extra load on the vehicle. And there you have it. Now the clutch is engaged. The low side has gone up to 50 psi and the high side is still at 50. Taking a little bit of time. That's cold. It's not cold just yet. So we're gonna get the temperature gauge and insert it into the vent to measure the temperature blowing out instead of just feeling for it. It's a more accurate measurement when you're using a gauge. Set it to medium. I think it's getting cold. Let's see what the pressures are at. There we go. So the low side is between 30 and 40, and now the high side has increased a little bit to about 80 or 70, which is good. And the AC compressor is still engaged. So let's go get our temperature gauge and measure it. If I can find where I put it. What do I do with it? Okay, I can't find it right now. Sorry, but we gotta keep an eye on this. We don't want to overcharge the system. So right now it's okay. It's at 40 psi here and close to 100 psi on the high side. That's good. These are normal readings. 30 to 40 psi on the low side, 100 to 150 on the high side. Gas it a little bit, give it some help. Yeah, it's getting cold. Wish I could show you. I don't know where my temperature gauge is. It's more colder in these two vents, so that's probably because my flaps aren't working. My mold doors are supposed to be channeling the cold air from the evaporator behind the glove box to the front registers, because that's where I have it selected. So if I were to select it here, the mold doors will channel the air to the footwell area here. But if it doesn't open up for both sides, you'll get cold air here and warm air here. I've seen that before, and that's usually because the mold doors, if your system is fully charged and there's no leaks, and yet only warm air blows out, then you can have a bad blend door as well. So when you switch to hot, red, it gets hot. And then the blend door opens up for all the hot air from the heater core to allow hot air to channel through these front registers. So if I go back to code, the blend door swings the other way to allow cold air to flow out now instead of hot air from the evaporator. The evaporator and the heater core are right next to each other behind the glove box inside of the distribution box. And a lot of times the blend door will go bad and it'll stick in one position, or sometimes it doesn't close all the way and allow a mixture of hot and cold air to enter the distribution box, and you get like a warm air coming out. That's because of a bad blend door, and there wouldn't be anything wrong with the AC system itself as far as refrigerant amount goes and compressor. If all that's working, then it's usually the mode doors or blend doors. So this part is blowing cold, that's cold, but that's warm and that's warm. Okay, pressures are still going up. You got 100 psi on the high side, and you got close to 40 psi on the low side. And if you touch here, it should be cold, and this should be hot. This is the suction side, where refrigerant enters through the suction line, and only gas should be entering through that line. And then this is on the liquid line. And every car has a label with the refrigerant type and quantity. And for this one, it's right up here. It takes 1.63 pounds of refrigerant of R-134a. Let me give you a better look at that. Right here. Charge 1.63 plus or minus 0.05 pounds of R-134a refrigerant. It's also in German. It shows 740 grams, which is equivalent to 1.63 pounds. So you might have to convert it sometimes. So it's still rising above 100 psi now, and the low side is still around 30 to 40, which is good. Still cold. This side's warm, this side's cold. Okay, that concludes it. Those are what your reading should look like for most cars. It really never changes on the low side. It's always 30 to 40, and then the high side can range from 100 to 150 to even 200 on a really hot day. Again, it depends on the temperature of the day and the refrigerant charge, if you have sufficient amount, that all affects the AC system. Okay, thank you.